Okay. Now you evaluate directly in the different factors that we have in our problem. The different factors are, you know, x plus 3, and x minus 1. You copy that. You copy x, one column for the x plus 3, one column for the x plus 3, and x minus 1. One column for the x minus 1. And one extra column in which I condensing the whole information. So it's called total column. Okay, now pay attention. Now you're plugging in one by one into the different factors, and you don't care the value, you care the sign. For example, -4, it's obvious -4. When you plug in -4 here, it's negative, no? It's negative. It's obvious it's negative, right? It's negative. So it's negative. You put negative here. Negative. I don't care the value. And when you plug in -4 here, in my mind, it's -4 plus 3, que es -1, no? And this is negative again. Okay, this is the idea. Do you follow me? And -4 here is -4, and -1 is -5. 3 negative. So I determine that the sign for the each factor is negative, negative, negative. Therefore, the total is negative because negative times negative is equal to negative. Okay. When you have even number of negative, even number 2, 4, it's a positive. When you have odd number of negative, the total sign is negative. Suppose -1. -1 is negative. -1 here is positive because -1 plus 3 is positive 2. And -1 is negative. In this case, we have 2 negative. So the total sign is positive. So I enclose in the circle the total sign because it's important. This the only important information in this table is the last column. So 1/2 is positive. 1/2 is positive here, and 1/2 is negative. 1 negative is negative. Okay, now 2 is positive. 2 plus 3, of course, is positive, and 2 minus 1, of course, is positive, and 3 positive is positive. Okay, we finished the table. Now we almost finished the problem. Now to finish the problem, I come back at the beginning. At the beginning is, look, our problem have greater than 0. That means this is equivalent to be positive. Therefore, the true guy in the last column is this, true and true. And the negative no is untrue. Okay, so the solution of the inequality is exactly the interval in which the testing point pass and the other keep fail, no. Okay, so basically is, let me highlight, -1, is this interval pass. Because when I testing using -1, was good, was true. And 2 also, okay, 2 start from 1, que is the critical value, to infinity. Okay, now conclusion. We have here parenthesis because my inequality do not contain equal sign. Si the inequality contain equal sign, entonces es obvio que es bracket, ¿no? Entonces, what is the final answer? The final answer is parenthesis -3, 2 pieces, union 1, infinity. End the story. This is the final answer. Any question, guy? What part is confusing? What everything is clear or no? Confusing or clear? Come on, I want to hear opinion. It's clear. Okay. This is the only way to do that? No. But in my opinion, it's the best way. Okay. This method is called changing sign method. Changing sign method. And this method contains one part, que is algebra, the first part, and another part que contains graphic part and table. So I want to see in the test everything together. Now some people, I don't know why, Don't put table, don't put graph. This is wrong. Okay? Well, we can do in another way, but it's different, completely different. This is the best way. Changing sign method. Okay, any question? Clear? Let's move on to the second example. Okay, let's move on to the second example. Example 2. And example 2, I change a little bit. Because I want to illustrate a new situation. For example, look at that. Suppose this inequality. X to the 4th power is greater than or equal 4x to the 2nd power. That's it. This inequality. Solve this inequality. Remember, important, extremely important. Right hand side and the inequality must be 0. Mandatory, guys. Some people try to simplification, cross multiplication. This is crazy. This is not good. I guarantee you. So the first thing you should do always is move everything to the left. Because right hand side must be 0 to start. Now, let me clarify why right hand side must be 0. Because in the table, we have positive and negative. And positive means, suppose this is 0. This is the level 0, a level of the C. Positive is up above, and negative is below. So the level 0 is super important to analyze this. Extremely important. Okay, nice. I understand now. Okay, therefore now factorization. GCF in this case is x squared. X squared minus 4 greater than or equal to 0. Now a difference of a square. So I need to totally factorization the expression in the left hand side. Okay, plus or minus. Okay, super. I finish. This is the point to start. My problem. Okay. Nobody can solve this inequality using this. Wow, crazy expression. It's crazy. This is totally crazy. However, you manipulate a little bit. Now, for me, it's more clear. I can see a polynomial, factory polynomial, in the left-hand side, and 0 in the right-hand side. Super. Now, I go to the critical value. The critical value are temporarily you convert the inequality to equation. Okay, equal to 0. Y I discover que x is 0, bueno, x squared, but it doesn't matter, x squared equal to 0 is equivalent to say x equals 0, but the multiplicity is 2, so 0, 0, but I don't need to repeat 0 only one time, negative 2 and positive 2. And this is my critical value. Okay, help me to create the partition of the all real number line. This is my famous all real number line, in which lie, of course, the solution for this inequality. But in 0, we have partition. In 2, positive, we have another partition. In negative 2, we have another partition. Negative 2, negative 2, negative 2, negative 2, negative 2. Now it's a time to create or to select, the testing point. Basically, we have 3 partitions. We have 4 intervals. We have 4 testing points. Maybe 1 is good. Maybe negative 1 is good. Maybe 3 is good. Maybe negative 3 is good. Suppose que another student select different testing point. The final answer doesn't change, because the behavior of any point you select inside the interval have the same. Okay, now ready to create the table. The table is testing point. You're listing the testing point. The testing point are negative 3, negative 3, negative 1. Okay, positive 1, and positive 3. Okay, how many columns we have in the table? Well, we have 4, but we have 3 factors, x squared. We have x plus 2 squared, no square, sorry. And x minus 2. And remember the important total, extra column. Okay. And you evaluate directly, plugging in this testing point into each one by one, and you get the, okay, this is not necessary parentheses, x plus 2, no? Okay. This is very, very interesting happening in the first column. I know that negative number or positive number, when you square, become positive. Oh, and also I know that the positive signs is not important in the selection of the total sign, because I count how many negative we have. Negative times negative, it's positive. Negative times negative times negative times negative is also positive, right? But si es even number of negative is positive. Si es odd number of negative, negative times negative times negative is negative, no? Odd number. 3 negative. This is 4. This is 2. This is 5 negative. 1, 2, 3, 4, and 5. Multiplication 4 or 5. Sorry. Negative number, the answer is negative. So the control of the total sign, que es the last column, que es the most important column, is depending basically the negative sign, not the positive sign. Therefore, I realize this is important. I want to explain in detail after that, que this column que contain exponent, this column que contain exponent 2, or even exponent, like that, even exponent, is completely irrelevant, and I can delete. Okay? So far, I want to explain in detail in the next example. So you have some factor que contain even exponent, you can delete. Entonces, it's a little bit complicated si es totally or partial. But in this case, totally. In this example, it's totally. Okay, entonces I focus in the rest of the factor que the exponent is not even, it's odd, it's 1 in this case. Okay, this is negative, this is negative, and 2 negative become positive. Negative 1 is positive, and negative 1 is negative. 1 positive is positive, 1 is negative, entonces es negative. 3 is positive, because 3 plus 2 is 5, 3 minus 2 is 1, is positive. Okay, super. I come back at the beginning, I can see that the symbol greater than or equal to 0 is because the true guy is the positive, no? So not always the true guy is the positive. In these two examples we are doing now is greater than, pero suppose que another example is less than, entonces the true guy is the negative. Pero no, this is not the case in our example right now. So the true is this, and the true is this. So basically, the testing point that passed the test was negative 3 and positive 3. The solution is this interval and this interval. Okay, I finished almost, because you consider the endpoint in the interval. Yes, we consider it because our example, our inequality is greater than or equal. Therefore, this is greater than or equal to. Therefore, the solution for the equation, by the way, is the critical value, belong also to the solution, because our problem is a combination inequality and equation. Therefore, you put a bracket here and negative 2, you put the bracket here and positive 2, and you include also the 0. que es one isolated point in the middle, que belong to the solution because 0 is the solution for the equation. So what is the final answer? Well, the final answer is answer is from negative infinity, comma negative 2 bracket, because including negative 2 inside the solution, because negative 2 is solution for the equation part, union. So you walking from left to right, you include 0, but 0 is one isolated point, and you using curly bracket to indicate one isolated point. Exactly, you using, for example, with the solution for the equation is 1, 2, 3, you put 1, 2, 3, like that. Well, it's interval, entonces you take care que es paréntesis o bracket. Pero si es one isolated point, you open curly bracket. Union, the last part que es bracket 2, comma, infinity. Any question? Is it confusing or it's clear? Super confusing or super clear? Clear? Aha! Very well. Okay, so now I want to explain in more detail what's happening when the coefficient, when the exponent is even and the factor or no. And if you delete or you don't delete or you partial delete or something, right? Okay, let me try. This is I call that guy special. Special cases. Special cases is when you are doing the factorization, for example, x minus 5 is a hypothetical example, no? X minus 4 squared greater than or equal to 0. I can see, wow, this factor contains exponent 2, que es even. Therefore, when you are doing, suppose I am doing the table and the column of the x minus 4 squared, always you see positive, and positive doesn't affect my answer. So I can understand very well that this is equivalent, it's the same thing to delete that part. So you copy x minus 5 greater than or equal to 0. Okay, because it's always positive. So you convert this complicated inequality, que I suppose it's a little bit complicated, and one super elementary easy, que not necessarily solving by table and changing sign method. No. We are solving the classical way, like the x minus 5 greater than or equal to 0, x greater than or equal to 5, and so you want to express it always, the answer in interval notation is bracket 5, comma infinity. Now this was one example in which you totally delete the factor que contain even exponent. Okay, this is my first special example. My second special example. Do you understand this or no? Suppose similar example. X minus 5. X minus 4 squared. But in this case, just greater than. Greater than, no, less than. Let's do it less than 6. Okay, we have similar situation. What's the only difference? Well, the only difference is this exponent again is even, and you can delete, but no total, partial delete. Yeah, I want to explain why. Partial delete. The reason is no total, it's partial, is because the value x equal 4, suppose que you plug in x equal 4. So you plug in x equal 4 here, is 4 minus 5, 4 minus 4 squared, should be less than 0. 4 minus 4 is 0, and 0 squared is 0, entonces in the left hand side we have 0, in the right hand side we have 0, and we have a contradiction. This statement is completely false. Therefore, what is the thing that we are doing? Well, you delete. Of course you delete, but partial. How? What means to be partial deleted? Well, okay, it's something like that. Look, let me show you. This is equivalent to say, I copy x minus 5, nice, less than 0, I delete, but you include and the no 4, like a whole and 4, because I know that the value of 4 is totally illegal, making introduce mistake. So you exclude 4. This to be partially. Conclusion. The factor que contain exponent even, you put no 4. Okay? Entonces, how you recognize que es totally delete or partial delete? This element is important. Si contain equal sign, totally delete. Si do not contain equal sign, partial delete. Okay? And how you finish this problem? Okay, we finish that problem solving this inequality. And consider the whole and 4. Let me try. You solve this inequality, x less than 5. And then we have a compound inequality. Normally, guys, the solution for the compound inequality we are doing graphically. Look, this is all real number line. Normally, we finish the compound inequality in the graphic solution because it's easy to visualize that. 0, 1, 2, 3, 4, 5. It's to the left. To the left is less than, to the left, right? But we have a whole and 4. Okay, I make a mistake here. This is not 0, this is 4. And 4 gets that point, we have a whole. Okay? So what is the final answer? Well, the final answer is answer. My solution for the minor inequality from negative infinity, 4, parentheses, because obviously don't touch 4, because 4 is a whole, union 4, 5. And in 5, we have parentheses also, because my inequality have no equal sign. And this is the answer. Let's see one more. Similar to the special case. Let me try. Okay, do you follow me? Do you understand? This is confusing. Okay, how do you know when you delete? You delete when the exponent of the factor is even. Maybe 2, maybe 4, maybe 6. And you partial delete when the inequality do not contain equal sign. No equal sign, partial delete. When there's equal sign, totally delete. You destroy totally. Help me to understand number 3 example. Okay, it's also similar, no? Yes, x minus 3, x minus 4, square greater than 0. Okay, you delete something or no? Yes or no? Hey, what's going on? Partially, very well. Sabrina say partial, professor. Okay, Sabrina. Sabrina say I copy x minus 3 greater than 0, so you care that part and that part, and it's going, but partial. And partial means que is no equal 4. And you convert our original problem in one compound inequality. And this compound inequality we solving, well, I solving separately that part. Okay, now to visualize, I need to do the graphic part. Okay, this is 0, 1, 2, 3, and 4. Okay, that part represents the interval greater than 3 is to the right. To the right is like that. Of course, do not contain 3 because I don't see any equal sign here. Therefore, the symbolic way to indicate this idea is using parentheses, no square bracket. However, I I partial delete, therefore C4 is a whole. Now what is the final answer? Well, the final answer is parenthesis 3,4 union 4, infinity. End the story. Super, 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 super easy, super clear, super everything. Okay, one more. Any question? Okay. I promise in the review package I want to send today, when I send the link for the connection for the YouTube video, you receive the review package, and we start doing this Wednesday. Okay. One more example. I change now something. I change the no polynomial anymore. No, it's rational. Suppose that we have rational. Okay, look at that. Okay, x plus 1, as greater than or equal to 0. Suppose I need. So on the left hand side, I have a rational function. By the way, it's expressed in factory form. So some people take care and factorization this. Okay, good. Okay, you save time. And on the right hand side, you have the famous zero that you always need to solve this. Okay? I promise the next example is not too easy like that. We need to manipulate a little bit algebraically. Okay, let's do it. So you take the expression on the left hand side and you find the critical value. Critical value in this case, we have rational division. There's a critical value of the polynomial in the top and critical value of the polynomial in the bottom. Okay, this is 0 and this is 2. This is 1 and negative 1. Wow, and we have 1, 2, 3, and 4 critical values. Okay, I understand. This is my real number line. I make it 4 partitions. Okay, 0 here in the middle, 0, 2, 1, 2, 1 and negative 1, 1 and negative 1, and negative 1. Okay, 4 partition. We have 5 interval. Okay, one more. And you select completely arbitrary testing point. Suppose negative 2 is good testing point. Suppose another student select negative 3, negative 4 is perfect because this is a citizen living in that country in this interval. Suppose here is negative 1/2. Suppose here is positive 1/2. Suppose here is 1.5 or 3/2, whatever you want. It's present decimal or in fraction, doesn't matter. And 3. This is my testing point. Okay, yeah, I create the table. TP. We have 5, no? Negative 2, negative 1/2, positive 1/2, 1.5. I don't know if you prefer in decimal or in fraction, either way, and 3. And you listing now the factor involved in the problem. And the factor involved in the problem, and the top is x minus 2. Wow. X minus 2. X minus 1. X plus 1. And total. Que is the column in which you summarize everything. Okay. The rest is easy. Plug it in. Okay, negative I want to do fast because this is basic arithmetic. Negative, negative, negative. The answer is positive. So because we have 4 negative, no? Negative, negative, negative. This is positive. We have the negative because we have 3 negative. Positive, negative, negative, and positive. So obvious, get positive because we have 2 negative. So even number of negative, the total sign is positive. Odd number of negative, the total sign is negative. Entonces this is positive, this is negative, this is positive, positive. The answer is negative because we have only 1 negative. And finally, everything is positive. This is obvious it's positive. Okay, we come back to the beginning. The beginning is greater than or equal to 0. That means the true guy is a positive. Whoa. Unfortunately, in this problem, everything the true guy is a positive, but not necessarily is. You see in the review package another situation. So what interval pass and what interval fail? This pass, and this pass. Our solution contains 3 pieces. The first piece is including negative 2. So from negative infinity to negative 2. Stop and negative 1, que es the partition. And the partition, remember, the critical value is the boundary que separate 2 intervals. One more is important. And half here, this interval is okay. And in 3, this interval is okay. Okay. What about the endpoint? Include the endpoint or no? Okay, yes and no. In this case, our inequality is a combination, or our problem, sorry, is a combination inequality and equation. Therefore, the solution for the equation is the top 0, the critical value of the top is included inside. And they never include the 0 of the denominator because you know that division by 0 is undefined. Now, entonces en 0 bracket and in 2 bracket and the rest no. Paréntesis, paréntesis. Okay, entonces my final answer is from negative infinity, comma negative 1, union, bracket 0, comma 1, union, bracket 2, comma infinity. End the story. Any question? What part's confusing? It's super easy. I know it's long, but this is not the point. The point is it's super easy. Okay, we have time to do one more interesting problem, and that's it. Any question, guy? No? Sure? Okay, you understand very well. Nice. I like that. Okay, let's do one a little bit more complicated. Look, suppose example, I don't know what number it is. 1 over x minus 2 less than or equal 2 over 3x minus 9. Okay, look at that. This is inequality. It's a rational inequality because of division, no? But some people make a mistake. Okay, look. Some people, when you face that problem, doing in that way, gets completely wrong. You apply cross multiplication. I like so much cross multiplication, but it's wrong. Because when you multiply, I don't know, you multiply something, it's a proportion, suppose less than or equal, another, right? Suppose that you apply cross multiplication, you multiply like that. Okay, super. It's box times box, and box times box. But what sign I put here? Less than or equal, the same, or I switching? I have no idea. Because I know that when you multiply by positive number, stay the same. But when you multiply by negative number, no. So I have no idea. Doing that way is completely wrong. And it's a classic mistake I saw in the test, when I graded the test. Okay? What should I do? As always I explain, the right-hand side must be 0. And you move everything to the left. Because I need 0 on the right-hand side. Okay? Now, leave it like that? No, of course no. because I have two fractions, I need to put together in order to manipulate the inequality. To say my goal is condensing this fraction and this fraction in only one compact fraction. Okay, so I can see, for example, I need to find the least common denominator, right? Least common denominator, least common denominator, least common denominator. Okay, but for finding the least common denominator, we need first factorization this. I can see that 3 is a common factor. Oh, now I understand now. The least common denominator is everything. You take 3, you take x minus 2, and you take x minus 3. This is my least common denominator. Okay, super. And I put the long line. In the bottom, I put the least common denominator. Okay, now I'm going to find the top part. I divide the least common denominator one by one by denominator 1, least common denominator by denominator 2, and multiplication by the corresponding top numerator, top 1 and top 2. Okay, when you divide, mentally, you divide this divided by the first denominator, que es this. Look, es obvio que x minus 2 is cancelled. And stay alive 3 and x minus 3 times 1, que es the corresponding top 1, is just 3 times x minus 3. Likewise, when you divide the least common denominator by the second, 3 is cancelled, x minus 3 is cancelled, stay alive only x minus 2 times 2. Do you understand this algebra? Of course, I don't finish, but we almost finish. We almost finish. Now I remove the parenthesis, apply distributive property. Distributive property. We have 3x minus 9 minus 2x plus 4 divided by 3x minus 2 and x minus 3. Less than or equal to 0. Okay, we combine later. 3 minus 2 is 1. Negative 9 and positive 4 is negative 5. Over 3 parenthesis x minus 2, x minus 3. Wow! And this is our fantastic compact expression that I want to start analyzing. Critical value, partition, okay? However, I have extra question. What is the extra question? We can delete this 3 or no? No? Yes or no? What do you think? I can delete this 3 or no? This 3 or no? This 3 is completely irrelevant or is important? It's irrelevant. Because remember, any factor gets positive, we can delete the inequality. Totally delete. Stupid thing. So this 3 doesn't affect. Suppose that we habilitate, put available one column, que es 3, pero 3 is plus. So this is ridiculous, right? I delete. Okay? So basic, not much better. Erase. Okay, this is my inequality so far that I need to analyze in detail. Okay. Now, critical value. Critical value of the top is 5. It's obvious. Critical value of the bottom is 2 and 3. Ready to make partitions. Infinity, negative infinity. This is 0, I suppose. 1, 2, 3, 4, and 5. Partition and 2, partition and 3, and partition and 5. Now selection the testing point. Testing point, good is maybe 1 or 0, whatever you want, 2.5, and 4, and 6. Remember, 3 partition, I need 4 testing. Okay, now ready the table. TP. TP is 1, is 2.5, is 4, and 6. The factor involved in my problem is x minus 5, x minus 2, x minus 3. I suppose that in that moment you understand more clear. Because if you include 3 here, this is stupid column, right? No, not good. Okay, now the sign. You plug it in 1 here, it's negative. It's negative, negative. 3 negative, it's negative. Okay, remember in the last column total, I put a circle to indicate this is important thing I need to understand. 2.5 is negative. This is positive. This is negative. This is positive. 4 is negative. Positive, positive is negative because we have only one negative. And 6 is positive. And the sign is positive. Oh, okay. Now I come back to the original problem. And the original problem say, wow, look at that. Less than or equal to 0. That means the true guy is the negative. Ooh, now the true guy is the negative. This is the true. This is the true. And this is untrue or false. Okay? Now the solution I discover of the outward inequality is 1, pass the test. Very well. Okay, 2, 2, because the boundary can change. Okay, one more, and 4. This is also true. Okay. And what about the endpoint? Include or not include in the side? Yes, include because our problem contains equal sign. But you include only the 0 of the numerator part. Okay, entonces 5 bracket and the rest is parentheses. That's what is the final answer. Well, the final answer is then from negative infinity. Final answer from negative infinity, comma 2, parenthesis union, 3, 5 bracket. End story. Any question, guy? Super easy, super clear. Confusing, complicated. Go ahead.
How come the ones that are negative are true? Because I thought that only the ones that were positive were true.
And which row do you say? So on the table.
Yeah.
What part you don't understand? Row 1, row 2, row 3, row 4.
No, the total. Like, why is the negative true and not the positive? Because for the other ones, the positive.
Okay. Super. I understand your question now. Look, because my inequality is less than, and to be less than 0 is equivalent to say that the truth is a negative. Less than 0 is below to 0, and 0 is negative. Clear?
Okay, yeah.
Super. Okay. Keep in mind, when the inequality is like that, or like that, the true guy you select and the positive. When the inequality is like that, or like that, you select the true guy and the negative. Okay? Okay, one more question. Okay, so remember, today I will send by email the review packet for the test 3. We start Wednesday. We spend Wednesday and next Monday. I suppose the test will be next Wednesday. Okay, any other question? Super. I suppose that you are working in the Alex. Any question? Everything that you don't understand, ask me by email or me or to me or the tutor. Okay? Okay, guys. See you. Bye.